Today, we're reasoning through the impact of aircraft characteristics on airport planning and design without hesitation, repetition, or deviation starting now. The challenge of accommodating a wide variety of aircraft at airports has always been central to airport planning and design. With aircraft ranging widely in size, weight, and performance, airports must be designed to cater to everything from small regional jets to massive wide-body planes. The physical dimensions of aircraft, such as wingspan, length, and weight, along with operational requirements, significantly impact how airport infrastructure is planned and adapted. This challenge is further compounded by the evolving nature of aircraft technology, necessitating continuous updates to airport facilities. Historically, airports have had to adapt to the rapid development of aircraft design. In the 1930s, the introduction of cabin-class aircraft like the Douglas DC-3 required airports to build longer, paved runways, replacing the shorter grass strips that were previously sufficient. The jet age, which began in the 1950s, brought even greater challenges as airports had to accommodate turbofan and turbojet engines, which demanded longer and stronger runways. Airports also had to consider noise mitigation measures due to the high decibel levels produced by jet engines. By the 1960s, the rise of jumbo jets such as the Boeing 747 led to a rethinking of airport design, particularly concerning runway specifications and terminal areas. The large volume of passengers and cargo carried by these aircraft required significant expansions in terminal infrastructure to efficiently handle the increased traffic. As aircraft design continued to evolve, so did the dimensional standards necessary for airport planning. One of the key considerations is wingspan. The wingspan of an aircraft runs from one wingtip to the other and dictates the width of taxiways, runways, and gate spacing. Aircraft like the Airbus A380 with a wingspan of 261 feet require much wider taxiways compared to smaller aircraft like the Bombardier CRJ200 with a wingspan of only 69 feet. Similarly, aircraft length, which runs from the front tip of the aircraft to the end of its tail section, is a critical factor in determining the size of parking stands and terminal gate configurations. For instance, the Boeing 777-200 with a length of 209 feet requires more space for parking and maneuvering than a regional jet like the Embraer ERJ-145, which is only 98 feet long. The maximum height of an aircraft, which is measured from the ground to the highest point of the tail section, impacts the design of passenger boarding gates. The maximum structural takeoff weight, or MSTOW, of an aircraft also significantly influences airport infrastructure. Heavier aircraft such as the Airbus A380 with an MSTOW of 1.2 million pounds demand runways that are not only longer but also stronger to support their weight. In contrast, lighter regional jets like the Embraer ERJ-135 with an MSTOW of only 41,800 pounds can operate on shorter, less reinforced runways. These considerations affect not only runway length but also the thickness and durability of the pavement used in aprons and taxiways. Another important consideration is the turning radius of aircraft, which is determined by the aircraft's wheelbase and nose gear steering angle. Larger aircraft require wider turns, influencing how taxiways and intersections are designed. For example, wide-body jets have larger turning radii, requiring airports to accommodate these wider curves. Meanwhile, advancements in aircraft design, such as swiveling main gear, help reducing the turning radius of larger aircraft, but the need for spacious intersections and taxiways remains. Lastly, runway length is perhaps the most critical dimension as it must accommodate a wide range of aircraft sizes and weights. Wide-body jets like the Boeing 777-200 require about 8,700 feet of runway for takeoff, whereas smaller jets like the Embraer ERJ-135 only need around 5,800 feet. Factors such as altitude, temperature, and aircraft weight further influence these runway requirements, making the design of each airport's runways unique to the type of aircraft it serves. In conclusion, airport planning and design must balance the diverse needs of modern aircraft while adhering to dimensional standards that ensure safe operations. This ongoing challenge requires constant adjustments to infrastructure driven by the evolution of aircraft design. As technology continues to advance, airports will need to adapt even further to accommodate new aircraft specifications and maintain operational efficiency.
If you like this video, don't forget to hit the like button, leave your thoughts in the comments, and subscribe for more aviation content.